Okay, trying to learn a little bit from my previous lesson. Don't go so long, so if the camera messes up, we don't lose as much time. We've seen that our surface area, our delta Sij, is 7/2 delta Aij, so that when we integrate the curl of f dot n with respect to s, and I've kind of written that as a little s, I need to write a big S to indicate surface area, so I'm going to kind of leave that the way it was with the colored marking to emphasize that that has to be a big S. Okay, our ds is 7/2 dy dx. Our curl of f dot n, our previous expression was this. I said that I messed up when I wrote this down. I didn't multiply it by 3. If I multiply it by 3, the 31 included addition of the 4, so everything else is going to be tripled, and the 27 that we added the 4 to is going to be tripled, and we're going to add the 4 and get the 85. So we really should be integrating this expression. And when we integrate the wrong expression here, we get 17/4. If we integrated the right expression, I think we would get the right integral that will agree with subsequent results. So we concluded originally that the curl of f dot n ds is 17/4. That's wrong. Okay, and we determined that that was wrong. And we see how we could have corrected it. Let's compare that with the other part of Stokes' theorem, the integral over the bounding curve of f dot t ds. Is that equal to 17/4? Well, it better not be. So the answer should be no, because 17/4 is wrong. If we get 17/4, we know that we're in trouble, but I knew in advance that we didn't get 17/4 for this integral, which is why I was on the alert for an error. Okay, now our region is bounded by a curve which is piecewise linear. We have a piece that we'll call C1 down in the XY plane, C2 in the YZ plane, C3 in the XZ plane, and our curve is then C1 plus C2 plus C3. We're going to integrate these in the positive direction. Not going to go through the details of how I parameterize these curves. I will say that I don't know if we've got the whole picture on here. Okay, I've parameterized C1 from t going from 0 to 1, x equal to t, y equal to 2 minus 2t, z equal to 0. Among other things, you can verify that if t equals 0, we get x equals 0, y equals 2, and z equals 0. If we let t equal 1, we get x equal 1, and so forth. And I've just discovered another error. This curve at t equals 0 gives us the point 0, 2 in the xy plane, which would be here. We're trying to integrate from this point to this point, from the x equals 1 point to the y equal to the x equals 0 point of the curve. So I've got this backwards. These should all be, each of these should be negative. X, actually no, x should be 1 minus t, y should be 2t minus 2. Now our C2 should go from 0, 2, 0 to 0, 0, 3. If t is 0, we get 2, 0. So our y is 2 and our z is 0, as it should be. X is 0 everywhere on this parameterization. 0, 0, 3, if t equals 1, we get 0 for y, we get 3 for z, so that works. If t equals 0 on our parameterization for C3, we get x equals 0, and that corresponds to the point 0, 0, 3. We get z equals 3, completing that. And if t equals 1, x equals 1, and z equals 0, and y stays 0. So there's an error and it's going to continue through these integrals, so we're going to have to make a correction, or at least indicate that a correction is required. Now for this parameterization of C1, our TDS, remember we're integrating f dot TDS. Our TDS is going to be what? X prime I plus Y prime J dt, something that we should be familiar with by now. And for this parameterization, X prime is 1, so we're going to have 1I, giving us I, and Y prime is negative 2, so we're going to have negative 2J. Now, this is wrong. This should be 1 minus t, so this should be minus I, and this should be 2t minus 2, so this should be 2 plus 2j. Again, we're going to go on with the way I've written it, but keeping in mind that we need the correction. Similarly here, y prime for the parameterization on C2 is negative 2 minus 2t. Y prime is going to be negative 2, so we're going to have negative 2j. Z prime is 3, so we're going to have 3k, and very similarly on the third parameterization. So that the integral of f dot TDS is the integral over C1 plus the integral over C2 plus the integral over C3. Now, using my incorrect parameterization of C1, I got TDS as I minus 2j times dt, and we're dotting that with our f vector, which is negative yi plus xj minus xz squared k. I've still got the x, y, and z here. I haven't yet substituted in the t coordinates, correct or incorrect. So I'm writing very carefully that t goes from 0 to 1, and we're integrating with respect to t to remind me that I do need to go back and substitute these parameterizations in for the x, y, and z coordinates. And similarly, I do the same with the TDS for the C2 and the same function for the f, and again the same thing on the C3 parameterization. If I do yi plus xj minus, well, if I do this dot product, I'm going to get negative y times 1 for the I component, which is going to be just negative y, x times negative 2 xj dotted with negative 2j, giving us negative 2x here. Again, that's incorrect. We have the incorrect parameterization. Fortunately, this one's fairly easy to fix. On the second integral, we have negative yi. We don't have an I component, so that contributes nothing. We have xj and negative 2j, so that's going to give us negative 2x. Negative xz squared and k and 3k is going to give us negative 3xz squared, so that we're going to have this integral, and here we're going to have this integral. Now, before we can do the integration with respect to t, we're going to have to substitute the y, the x, and the z parameterizations in. The y and the x from our first parameterization in this integral corresponding to our second segment, this integral corresponding to our third segment. And when we do, we get the result you see here. Now again, this one's wrong. Maybe we'll take a minute to fix it. But if we substitute the x parameter, which was t, with our incorrect parameterization, is going to become 1 minus t. But if we put t in for the x here, we get our negative 2t. If we put 2 minus 2t in for our y, we're going to get negative y, which will be negative of 2 minus 2t. With that parameterization, this whole integrand then just reduces to 2 dt. Now that's wrong. We'll have to fix it. Okay, over here for the second integral, we see that we have negative 2x and negative 3xz squared. We don't have a y in here, but what we do have is we have an x on each term. And on our parameterization for C2, remember C2 is this part of the integral, and that's in the yz plane. X is equal to 0 everywhere here, so that our x's will both be zeros This is what we get if we substitute, but this integral just gives us 0. Our third integral, if we do the same thing, substitute t for x, 3 minus 3t for z into this expression, this is what we get. Y is 0 on this third part of our curve, of our boundary, as we see stated clearly in the parameterization, so that the negative y is not going to give us anything. The 3xz squared gives us this. And if we expand this, I've factored the 3 out of the square, and I factored a 3 here, giving me 3 factors of 3, 27. And then I've just got t times 1 minus t quantity squared, which I believe gives me this. So that this integral becomes very simple. We're integrating from 0 to 1. We're going to have t squared over 2, which is going to give us 1/2. Negative 2 t cubed over 3, which is going to give us a negative 2/3. T to the 4th over 4 is going to give us a 1/4. Put those as a common denominator of 12, and we easily get a result. And I think the result is 1/12, so we get 27/12 out of this. We don't get 2 here because of my erroneous parameterization, so that my former statement that this is probably right, nope. Okay, the integral from 0 to 1 of 2 dt should have been, and I might try to do this carefully, let's trace it back, our t ds should have been negative I plus 2j. Our x should have been 1 minus t, our y should have been 2t minus 2. So our t ds here should have been the negative of what it is. Our x should have been 1 minus t, so let's see, our negative y minus 2x should have been negative 2 times 1 minus t. And our minus y, our y should have been 2t minus 2. And this whole thing should have been negative. So we should have had the integral from 0 to 1 of this. And that would be the integral of negative 4t plus 4 dt, integral from 0 to 1. And that would be negative 2 plus 4, which comes out 2. There's obviously symmetry in these expressions that I kind of suspected but didn't really believe. It's, as I say, a little bit late, so forgive me for that, but it looks like this answer might be right. So I'm going to say, well, maybe, and I'll leave it to you to sort it out.